Hello guys, welcome back to my channel. This is chemistry call. Today we'll be looking at another topics under the topics which I promise to drop for those preparing for Jamb 2020. Last week I dropped a topic on chemical equilibrium, which I explained the concept of chemical equilibrium. So this afternoon we'll be looking at redox reaction. Before we proceed, I would like to appreciate the effort of our subscribers for sharing and also for the comments given. So this afternoon we'll look at a good topic on which is redox reaction. And as a Jambite, what are the things you ought to know under this redox reaction? Before this redox reaction, as a Jambite, you ought to have a full knowledge of what we call oxidation and reduction, oxidation number. So these two has been deposited on my videos. So for you to have a full knowledge about this redox reaction, you ought to have understand the concept of this oxidation and reduction and also oxidation number. So let me just make it brief for this oxidation and reduction. So when talking about this oxidation and reduction, we have four different headings that explain the concept of this oxidation and reduction. The first one is addition of oxygen. So while the second one is removal of hydrogen. That is, under the addition of oxygen, oxidation means as the addition of oxygen, while reduction means removal of oxygen. While under the removal of hydrogen, oxidation can further be extended to mean removal of hydrogen, while reduction means addition of hydrogen. And the third one is addition of electronegative elements, that's for oxidation, while removal of electropositive elements. And the last one is transfer of electrons. So that is where we are picking the definition of this redox reaction form. So now, what is redox reaction now? So redox reaction, I can say from the four elements of oxidation and reduction, I can say that reaction in which involve the transfer of electron, which takes place between a reactant. I can say redox reaction is in which takes the transfer of electron, which takes place between a reactant. For example, now I have A plus B. The area we have A plus B. So now this one indicating going for this, I have a positive here. While this is going to this, I have the what? A negative here. So how does it imply that there exists what we call the transfer of electron, which takes place between a reactants. So now these are the reactant side now. So if you truly want to understand the concept of redox reaction, you ought to have known how to differentiate between the product side and also the reactant side now. Because mostly for every redox reaction, they occur as the reactants. So now, with this now, I can say I have what we call oil, and also what we call what? Rig. So telling that if there exists an electron donor and also electron acceptor, the electron donor means loss of electron. So now I can say oxidation is loss, while this, I can say reduction is gain. Are you with me now? So this point now, we cannot use these two now. So this loss and gain to explain the word the transfer of electron, which takes place at the reactant side. Now we have this equation now, A plus B. At the product side, the A carries a positive sign, B carries a what? A negative sign now. And don't forget in chemistry that the one that lost electron, we have a positive sign. The one that accepts electron, that gain, we have a what? A negative sign. So tell you guys that what this B as what? The rig, that is the reduction is gain, while this my A will act as what? Or oxidation is loss. So that is the explanation of redox reaction. So take note that there are two main types of redox reaction which occur mostly at the reactant side. The first one is oxidizing agents, while the second one is reducing agents. You can see now, these are the two main types of the reactant side at which they occur. So the first one about this oxidizing agents is, take note of one thing here. Here is what we call electron acceptor. That's for the oxidizing agent. Take note of that. We have this now. So substance is being reduced. Another point about these oxidizing agents, substance in which the oxidation number decreases in the positive direction. So these are the 3 points we ought to know that is oxidizing agent. Then I'll also give a further definition of this oxidizing and reducing agent. So for this reducing agents now, the first point we have to cite here is electron donor. The second one, so if the substance here is being reduced, then for reducing agents, the substance will be oxidized. That's the second point there. They said substance in which the oxidation number decreases in the positive direction. So you can see it now. Positive direction. So now the third point will be substance in which the oxidation number increases in the positive direction also. Can I say it now? Substance in which the oxidation number increases in the positive direction. So what do we want to use here? Is two things here. Oxidize. One for these. You can say what? Reduce. So now let me cite this good example now. So now if I have A B2 plus C, moving to this place now, I have A plus B2C. So let's see how truly if we can use this to explain the concept of oxidizing and reducing agents now. So for this AB2 here, are you with me now? So moving to the other side, it is being reduced from AB2 to what? A. And when a substance is being reduced, it is called what? Oxidizing agent. That is OA. So I take this to my what? OA. Why for this? RA to be my reducing agent now. So this C here is being oxidized to B2C. So my C here is the reducing agents. Again, if we are given an equation, the way you can consider your oxidizing and reducing agent is start from the reactant side, because we lay more emphasis on the transfer of electron which takes place between the reactants, or you can use between the reactants. So this one here will show you guys that for every oxidizing agent, a substance is being reduced. That is, there is what we call electron acceptor. While for the reducing agent, there is electron do not really exist. Whereas we also have poles where a substance is being oxidized. One thing we should note about this oxidizing and reducing agent is not until from the word oxidize means the substance should be the one that will oxidize. No. The substance which is being an oxidizing agent means that the substance is being reduced, while the one that is being or that acts as a reducing agent, it is being what? Oxidized. So that is why we have what we call the oxidant and the reductant. So now let's take a look at another definition of OA, which is our oxidizing agent, and RA, which is our reducing agent. So you can say my OA oxidizing agent is substance which is being reduced in a chemical reaction, thereby bringing about oxidation. This is another definition of oxidizing agents. So let's take a look at this now to define our reducing agents now. So you can say reducing agents are substances that are being oxidized, thereby about reduction. So now here we identify oxidation, and also here we also identify what? Reduction. So that's why I mentioned earlier that if you want to have a full knowledge about this redox reaction now, you should have the knowledge of what we call oxidation and reduction, and also oxidation number. So this is a clear picture of how to identify our oxidizing and reducing agents now. So now I would love to play with some examples here before we move to that of the Jamb question. So I have this. The first one is the first example. For the first example, I'm going to play with the second one. I'll play with this also. The third one. So now, why the fourth one is so now, these are the 4 examples I'll be playing with. So, when looking at this now, these are the explanation of redox reaction, oxidizing agents, reducing agents. Now, we have copper 2 oxide at the reactant side. We have carbon monoxide, we call it carbon 2 oxide. So at the reactant side, the copper 2 oxide is being reduced to copper 2. So you can see it now. Copper 2 oxide is being reduced to copper. And when the substance is being reduced, that means what? Oxidizing agents. And for this, which is carbon monoxide, or we can call it carbon 2 oxide, is being oxidized to give us what we call carbon 4 oxide. And when the substance is being oxidized, to give us what? A reducing agent. So now, what we want to identify again is what is a reduced substance and also what is what? Oxidized substance. Being that copper 2 oxide here is being reduced to this. So copper 2 will be what? Reduced substance. While this will be my oxidized substance. I see it. Of course, in your Jamb, the question can become different from that. Identify the reduced and the oxidized substance. So how will you be able to? So note one thing that I told you earlier that if at the reactant side the copper 2 oxide is being oxidized or is being reduced, because it's obvious that the copper 2 oxide here is being reduced to what we call copper 2. And when the substance is being reduced, we have what we call oxidizing agents. So now, let's take a look at the second one. Also, you also have the same thing here, copper 2 oxide plus hydrogen gas. So, when this copper 2 oxide here is being reduced, we are having what here? Copper 2 oxide. So, if you use this arrow now in this form and also this in this form, this will act as my reduction, while this will act as my oxidation. That's why I told you that oxidation is it means the addition of oxygen, which is this, for oxidation. Why this means the removal of oxygen for reduction. For this, addition of oxygen means what? Oxidation. So now let's identify the reduced substance and the oxidized substance. So copper 2 oxide here is being reduced to copper. So this is my oxidizing agent, while this is my reducing agent, because the hydrogen gas here is being oxidized to what? Water. We can only call it hydrogen gas as the reactant side, but moving to the product side, we have water. So copper is the reduced substance, while water is the oxidized substance. So the third one, I have here, you also have water. So this is my iron tetraoxide and this is my what? My hydrogen gas. So is this now? So this is kind of very complex, but it is very simple if you follow the rules itemized here. So this is my iron here. I have this also. The difference between iron and this is the number of mole. So at the reactant side now, I can predict the oxidizing agent and the reducing agent now. So look at this iron. So moving to the product side now, iron is being attached to another what? Form of oxygen. Here we have 3 of iron now. But moving to this place, we have 4 oxygen attached to our iron. And when oxygen is added to a substance, that's it again. When oxygen is added to a substance, that substance is called oxidation. When oxygen is removed from a substance, that's what is called what? Reduction. Under the addition of oxygen. So now, here, this is my iron here. We are moving to this place and this. So I can easily identify that oxygen is added to this iron here at the product side. This is my oxidation. Oxygen is removed from a substance. This is my reduction. So now we know the oxidation, we also know what? The reduction. So let's identify our OA and our ROA. Don't forget the meaning of OA, oxidizing agents, ROA, reducing agents. So this iron here is being oxidized to this. So that's why you look at I said oxidizing agent is a substance which is being reduced in a chemical reaction, while reducing agents are substances that are being oxidized thereby bringing about reduction. So now this ion here is being oxidized towards this particular compound here. Why for this now? This water here is being reduced to what? Hydrogen gas. So what you want to identify is if a substance is being reduced, we call it what? Oxidizing agent. When a substance is being oxidized, we call it a reducing agent now. So that's why I told you earlier that this question is kind of complex compared to the other one we have been solving. So now, my ion is being oxidized to iron tetraoxide. Are you with me now? So now, when the substance is being oxidized, we have what we call a reducing agent. So this now, don't forget that anytime you are removing water or adding oxygen to a substance now, so this is being reduced to hydrogen gas. Are you with me now? And when the substance is being reduced, I can take it to the what? Oxidizing agent. So if you are taking this to the oxidizing agent, to me, it means you did not understand the concept of this oxidizing and reducing agents. Because when you look at the first one I saw, the second one I saw, you can see when you are removing oxygen from the substance, that brings about what? Reduction. And that is what? Oxidizing agents. So yeah, I'm removing oxygen from this compound, also bringing about what? Oxidizing agents. So you can say that the case is different from what you have here, and the 10 example you have here. So these 3 examples here shows how the substance are being oxidized and how they are being reduced. So the last one, which is the 4th example now, I have hydrogen phosphide at the left side and also my chlorine. Anywhere you see your chlorine is a good example of oxidizing agents. So you have to stress yourself. Take note. Anywhere you are seeing chlorine acts as oxidizing agents. So now, if chlorine acts as oxidizing agent, how do we explain the concept of this now? Listen, hydrogen sulfide is being reduced to sulfur. So now, when it's being reduced to sulfur, then we'll call it what? A yellow sulfur. And this chlorine here is being what? Oxidized to what? Hydrogen chloride. But chlorine is a good example of oxidizing agents. So the vice versa, that if truly this is being reduced to this, which you all know that when the substance is being reduced, we have oxidizing agents. And if truly, when you have this chlorine gas, it's being oxidized to hydrogen chloride. That is what we're using agent. But because chlorine is a good example of oxidizing agent, so automatically here will be my reducing agent. Because this is being oxidized to give us what? A yellow sulfur. So I just want to know what oxidizing agents. So this, for example, will serve as a guide. So you have also identified your oxidizing and reducing agents. So now the next thing that we look at now is what we call a balancing of redox reaction. Balancing of redox reaction. Before we move to the 10th question, we have promised that I will drop on each topics I touch. So if we have this, are you listening now? This is one example of the kind of thing you are going to come across. Plus hydrogen, here we are, Mn2 plus H2. I see this now. So with this example now, we can decide to play with some Jamb question which will serve as a guide to us. So now, let me have ion 3 here. We have ion 2 here. I also have ion 3 here. The first thing you are going to identify here is this. You bring it in this form because we want to talk about the balancing of redox reaction now. So with this now, bring out the two compound. We have 4 here. We also have what? 2 positive here. And here we have Fe2 plus here. We also have what? Fe3 plus here. Ionic now. So now how can we balance this ionically? The first thing you are going to do here is you have to look for the oxidation number of manganese. Earlier I told you that for you to have a clear picture about this redox reaction, you must have understand the concept of oxidation and reduction, and also how to calculate oxidation number of a compound. So now, we have to calculate the oxidation number of this manganese now. So we have this negative. Don't forget, I want to use that governs oxidation number. The aggregated charge of any compound given will be equal to that compound. So the charge here is what? -1. So our Mn plus what is the valence charge of oxygen? We all are aware that oxygen have a negative charge of 2. So in the bracket we have -2 times oxygen plus the bracket is equal to what? The aggregated charge of the compound, which is -1. So plus times minus, we have minus. 2 times 4, we have 8 is equal to -1. So our Mn is equal to -1 plus 8. So this will give you what? Mn is equal to plus 7. So here now, we have plus 7 here. And if you have a substance that from plus 7 to plus 2, this is what? That gives us what? There is decrease in the positive direction of the oxidation. So this serves as my oxidation because there is decrease. Because we said earlier that for every oxidation, there must be what? Loss of electron for oxidation to occur. While for reduction, gain of what? Electron. So for this now, from plus 2 to plus 3 is increase. So we have reduction. I see it now. Plus 7 to plus 2 oxidation because the charge here is plus 7 and the other charge here is what? Plus 2. So there is an increase. So there is a decrease there. While for this from plus 2 to plus 3 we have what? Reduction. So now let's play with it because this manganese here carries 4 oxygen. While at the reactant side for this does not have any particular one. So I think this one to be my equation 1, while this to be my equation 2. So with this, like I said, I have MnO4, negative sign here. We have Mn2 plus. Don't forget the charge of the manganese. We have plus 7. I say it now. So how many oxygen do you have? 4. So automatically as the product side, we are adding 4 of water. Why are we adding that water to it? We are adding that water to it because we want to balance it in acidic medium. And for it to balance it in acidic medium, there exists what we call what? The positive hydrogen ion. Because for it to have an acidic medium, it means you have H2O plus hydrogen ion, so we have what we call what? Hydrozonium ion. I said it now. So now, the oxygen will determine the number of water to be added to that equation given. So here we have 4 H2O. You can see now. So now, for it to be added with water now, it is also affecting the reactant side, because here you only have 4 of oxygen, but here you have 4 of oxygen. 4 times 2 give us what? 8 hydrogen. So we have plus 8 hydrogen. Are you with me now? So with this, I can say the charge here is what? Plus 7. This arrow shows that we have a negative sign here, minus this. So the number of electrons that this manganese is losing. So 7 minus 2, we have plus 5 electrons. So in Jamb, these 5 given, don't just know how to calculate for it that the number of electron loss here minus the number of electron loss as the both side give you the number of electron that both the reactant side and both side lose. So 7 minus 2 give us what? 5 electrons. So in Jamb can decide to just omit this number here and also omit this number here. Then ask you that what is the number of hydrogen atoms that will be pumped into the compound and how many electron loss that will occur in the ionic equation. So I can take this to be my equation 3. So now the next one, these 2 plus, we also have this Fe3 plus. So this charge we have here cannot occur reactant side together with this. So automatically the second one will occur. So now 2 minus 3 give us what? Minus E electron. So if we are taking this to this place now, the negative charge here will change to what? A positive charge. So with that, like I said, I have Fe2 plus and Fe3 plus 1 electron. So this gives us what? Equation 4. Note one thing. When it comes to this redox reaction or balancing redox reaction, the first thing we should understand most is how to calculate the oxidation number. That's number 1. Number 2, how to identify oxidation and how to identify reduction. If you can get the full picture of oxidation and reduction and how to calculate oxidation number, which I have deposited on my videos, you can check that for you to have a clear picture of what we call redox reaction. Guys, don't forget to subscribe to the channel as you are watching. Thank you. So now, let's continue with what you have here. So now, we are going to bring the reactant side together and also bring the product side together. But before we do that, the charge for manganese is, for this equation 3 is 5. The charge for equation 4 is 1. So you have to multiply the charge of equation 4 by that of what? Equation 5. So multiply by 1. Then the charge of equation 3 by all the equation in equation 4 multiply by 5. So when you do that, 1 times this one will give us what? MnO4 negative plus 8 hydrogen ion plus 5 times 1 will give us what? 5. We have 5 times Mn2 plus, we solve it. 4 times 1, we have this. So still we take that equation. No, 5 times Fe2 plus, so we can say we have 5 Fe2 plus. There are what? 5 Fe3 plus. 5 times 5 electron, we have what? Plus 5E electron. So are you with me now? So with what we have here, let's combine the reactant side now. Then we'll cancel out the charge. So say if truly the reactant side and the product side is balanced. So now, this now, instead I have, so Mn plus this 5Fe2 plus the 5 electron here. Then we have Mn2 plus 4H2 plus 5Fe3 plus 5E electron. So I will now. So now, this charge here and this charge here we have to what? Remove. So doing so, cancel this. We cancel this now. So we are left with Mn O for negative plus 5 Fe 2 plus. We have Na 2 plus 4 H2O plus 5 Fa 3 plus. So these are the balanced ironically. So now let's look at the number of charge now. Minus 1 times 1 we have what? Minus 1. 1 times 8 we have what? Minus 1 plus 8. That will give us 7. That aside. So 2 times 5 we have 10. Mind you, say minus 1 here, plus 8 here, plus 10 here. So here we have what? 17. So let's check here. Plus 2. There's no charge here, is 0. 5 times 3 we have what? 15. So 2 plus 15 we have 17. So this is balanced ironically. So this is how to balance a redox reaction. The reason why I expose you guys to this redox reaction is there are some questions that you might not be asked how do you identify the oxidizing and reducing agent? Rather, you can be asked that how can you identify the charge and the number of hydrogen atoms added to the substance. As I told you earlier that in Jamb, this 8 here can be replaced with any letters. This 5 here can be replaced with any letters. So now, let's play with the 10th question, which I promise you that for every topic I explain, I will drop 10 questions which I will explain and relate it to the topic which I explained before. So now, class, excuse me, so now we have a clear picture of how to identify oxidizing agents, reducing agent, and also how to balance a redox reaction, and also how to find the missing elements and the missing number of the electron. So guys, don't forget to subscribe and also share among your colleagues. So now let's play with the 10 Jamb question. So the first question we have here is Jamb 2010 question. So the first one is, that's the first one. First question there. So we have 6 of silver nitrates, plus this. So in the above reaction, what is the reducing agents? So the first one you have here is HNO3. The second one is H2O. So now, looking at what's here on the board, as you can see now, I said in the above reaction, what is the reducing agent? Don't forget that the reducing substance will be what? Oxidized. And the options are given. So question like this, don't forget when I explain the time maximization, I say for every question in Jamb, spend nothing less than 40 seconds. So now, when you look at this now, say from this to this place, it is being reduced. Are you with me now? This here also, it is being oxidized to this. While my water here also is being oxidized to HNO3. So now, how can we identify the answer to this question? So in the above reaction, what is the reducing agent? Now, so now let's write it out. We have AgNO4 plus PH3 plus this 6Ag plus PO3 plus 6HNO3. This was given to us. So this one here, AgNO4, so this PH3, this PH3, PO3, this to 6HNO3 now. Let's take it like this. If we can guess, this will make you or gives you a clear picture of how we can have an answer. So now, AgNO3, this one is being what? Reduced to this. So this one is out of it. So we can't keep this. It's out of it. This now, when combine this and this together, so like I said, I have PH3 plus this, I have H3PO3 plus HNO3 now. If this is out now. So now, PH3 here now, we go with this. This PH3 now is being reduced. Sorry, it's being oxidized from this to this. While your water here now is being reduced also to HNO3. So now, if my PH3 is being oxidized to give me POH3, again, if this PH3 now is being oxidized to give this, then what will happen to this water? Because PH3 now give us this, right? This water here give us this, which is HNO3. Are you with me now? So this PH3 here now is being oxidized to PH3, H3PO3, that's hydrogen triorgophosphates 5. Are you with me now? So if this PH3 here now can be oxidized to give this, then what will happen to this water? Then the water will be reduced to what? HNO3. So that is why in Jamb you always have two options to pick, the most correct one and the correct one. So now, if this one is acting as my reducing agent as PH3, then my answer is PH3. If you decide to go with this water, mind you, I said for every oxidizing agent, the substance will be reduced, while for every reducing agent, the substance will be oxidized. You can see now, both carry the number of hydrogen atoms from the product side. I have 3 here, I also have 3 here. But here, we have produced what we call nitrogen here. So, this PH3 here now have been oxidized to give me what? Hydrogen triorgophosphates 5. So, my answer is C, this. Take note of that. So, I'll pick another question now. Pick another Jamb question now. I have, this is Jamb 1991. The question states NaO4, we have negative sign plus this plus Ne. This looks familiar to what I just solved now. Plus 4H2 under the balancing of Redox reaction. So, which is the value? Which is the value of N in the reaction above? So, A, I have 2. B, I have 3, C, I have 4, D, I have 5. So now, what is the value of N in this collection? Yeah, so the first thing I have to do is bring these two out, because these are the only things that can identify the charge of what you are looking for, the value of N. Don't panic because you have identified it already. We have 4 oxygen here, I also have 4 oxygen here. I have 8 hydrogen at the other side here. I also have 8 hydrogen at the reactant side here. So now we are looking for N. So let's bring out the equation now. So I have MnO4 with Mn2 plus. I don't have any demand at the product side because I know the charge already, but for this I don't know it. So let's calculate. So this will be equal to what? Minus 1. If you watch the video under oxidation number. So I have Mn is equal to what? The applicated charge of the compound. So now Mn plus the valence charge of oxygen is minus 2, the substitute here is what? 4 is equal to minus 1. So Mn plus, yes, I can see this plus here, 2 times 4, that will minus 8 is equal to what? Minus 1. Plus times minus, I have minus 8 is equal to minus 1. So taking this one to this place, I have what? A positive sign. So Mn is equal to minus 1 plus 8. So my Mn will give us what? Plus 7. This charge we have here not determine that we have the answer, but it will give and serve as a clue to that answer. So put your positive sign here. And mind you, when I was explaining the balancing of redox reaction, I said there's what? A negative sign here. That the value from the reactant side will subtract the value from the product side. So here we have negative plus 7, the minus sign here, we have what? Plus 2. So 7 minus 2 will give me what? Plus 5. So you can see that the value of N in the reaction above is what? 5. This is what? D. So you can see that for you to have a clear picture about this, you also have watched the video which I dropped on oxidation number. Then you will be able to identify the charge has been what increased. So the third question is on the Jamb 2003. If Y is an oxidizing agent that reacts with a reducing agent Z, which of the following is correct? Which of the following is correct? So A, Y increases in oxidation number. B, Y become reduced. C, Z lose proton. D, Z gains proton. So you see now. It said if Y is an oxidizing agent that reacts with reducing agents Z. So if we have Y plus Z, when they react together we have what? YZ. Don't mind, they say Y is OA, R is Z is RA, which is the oxidized substance. Which of the following is correct? So now, Y increases in oxidation number. Don't forget that for every oxidation, for every oxidizing agent, the substance is being reduced. There is decrease in the direction of the oxidation number. That's number 1. So Y increase in oxidation number. that is wrong. Because for our Y to be the oxidizing agent, there must be what? Decrease in oxidation number, not increase in oxidation number. So A is wrong. So B, Y become reduced. Yes. Y, for every substance to be an oxidizing agent, are you listening now? For every substance to be an oxidizing agent, then the substance must be what? A reduced substance. Okay? Let's go C. Z lost a proton. The word proton means a positive charge. So Z lost proton. From that word, reduction means gain. You can see that mostly Jamb reduction is not something that you can just find cheap. And you go there and just pick any answer. No. You have to think because you have the answer. So Z lost proton. No. For every reducing agent which bring about reduction. So I know for that reduction is what? Gain. So C is wrong. So now let's check between B and D. Z gain, our Z gains what? Proton. How? They did gain what? Proton. So for this now, for it to have gained a proton, are you with me now? Then it cannot serve as what? Oxidizing agent and also as what? Releasing agent, because my Z here given here says what? With a reducing agent Z. So the correct one is Y, become reduced. Because Y is an oxidizing agent that reacts to what? Reducing agent. So statement A here is wrong, C here is wrong, D is partially correct, but the correct one is what? P. Because when we have this, our Y is being reduced. So here you can also act as what? Reduce substance. So our answer here is what? B. So let's go to the next question. The fourth question. States that, okay? Yeah, 2004. Which of the following acts as both reducing and oxidizing agents? So A, we have hydrogen gas. B, we have SO2. C, we have hydrogen sulfide. D, we have CO2. So they ask that which of the following acts as both reducing and oxidizing agents? Are you with me now? Which of them both are? So now, hydrogen now, for example now. Hydrogen is an example of oxidizing agents. So A is not there. Sulfur oxide can act as reducing and oxidizing, but for it to have this, which is your sulfur oxide, so this acts as reducing agents. This acts as oxidizing agents. This acts as reducing agents. But this now, the last one can be determined if truly is it what? Can act as reducing agent and also what? Oxidizing agent. There are some compound. Listen, there are some compound that can act as oxidizing and reducing agent. Example is you can use carbon dioxide and water. They can act as oxidizing and what? Reducing agents. So here, this is a reducing agent at one end. So now, we are reducing agent, oxidizing agent, reducing agent, and what? Also reducing agent. But the question is, which of the following act as both reducing and oxidizing agents? The only one that can act as both reducing agent and also as oxidizing agent, we have two. This and this. So now, look at this now. Which angle is the most correct? And which one is what? The correct. Are you with me? So the answer for this is D. Because D can act as oxidizing and reducing. For example, if you have this plus, yes, moving to this place, you have this plus what? O2. So here now, this one is my what? And this one is my what? OA. So here we have the reduced substance. Or this one is my what? Oxidized substance. So vice versa. So let's take a look at another one now. Before we can conclude on the last answer. If the answer is D or C. So is this now? I have hydrogen sulfide plus chlorine gas. I have hydrogen chloride plus sulfur. Listen very well. The example I gave earlier, which I saw, this one here can reduce, has been reduced to what? Sulfur, but it is not acting as oxidizing agent. Rather, it is acting as what? Reducing agent. So automatically now, this hydrogen sulfide can act as reducing and oxidizing it because the hydrogen sulfide here is being reduced to sulfur here. But the sulfur here is acting also as what? Reducing, sorry, as the oxidizing agent. So the final answer here is what? C. This one can act as oxidizing and reducing agents. Compared to what I just, the equation I dropped here now. Here, we say the substance is being reduced to sulfur, but it is not example of what? Oxidizing. Because when you change it to the other side, I have what? This. And I have what's here? Hydrogen sulfide plus chlorine gas. So sulfur here is being oxidized to this. So when it's being oxidized, you have what? ROA. This one is being reduced to what? This. OA. But here we have what? ROA. OA. So this can act as oxidizing and also what? Reducing agents. So to have our answer, now, we have to be very, very careful. I explained it now. This also acts as what? Oxidizing and what reducing. So the best has to pick here, our advice, and this how it goes. Not even advice, based on the explanation. The correct answer is what? Carbon dioxide. So our final answer is D. So the next one, that's our main question now. 4. The next question is Jamb 1988. State what is the possible oxidation number? What is the possible oxidation numbers of an element if its atomic number is 17? A minus 1 and 7, B minus 1 and 6, C minus 3 and 5, D minus 2 and 6. So now these, the question we'll be playing now. I listen now. This question we'll play it now. So is this now the same? What is the possible oxidation number of an element if its atomic is what? Atomic number is 17. Now, so the element with atomic number is 17 is chlorine. Are you listening now? And the electronic configuration of chlorine is 1:2 2s2, 2p6, 3s2, 3p5. So this we have 287. And for you to identify the charge of this now, so this 7 here, good. So you can say 7 minus 8 will give us minus 1. So we have minus 1 here, but the group number here is 7. I have minus 1 here. The group number here is 6 wrong. Minus 3, group number 5 wrong. So the answer is what? A. Because from group 5, 6, 7, 8, their group number was subtracted from 8. So that is why oxygen group number is 6. 6 minus 8 we have minus 2. Chlorine group number is 7. 7 minus 8 will give us what? Minus 1. So the next question. The next question is, okay, another Jamb question, 1994. 1994, we have S2O3, so minus, plus this. We have S226 plus 2. So in the reaction above, the oxidizing agent is, so now we have A, SO2, B, hydrogen, C, so now, looking at what you have here, so I'll put this to explain. So looking at what you have here now, I said this equation you have here in the reaction above, the oxidizing agent is what? So now look up. This one here is being reduced. Listen attentively. You can see the number of oxygen here is 3 here, but here we have 6. So be careful with this kind of equation. So the iodine here is being reduced to what? Iodine gas here from, so now let's itemize it. We have S2O3 minus plus this. Okay, let me take it that one for you. So we have this. This is there. So now, we must identify the oxidizing agent. Don't forget that all is what? When the substance is being reduced. So yeah, I have a 0. Yeah, I have 1. Because I said any elements in an uncombined state have the charge of 0. So minus 1 times 2 we have what? Minus 2. So from 0 to minus 2 is what? Is it an increase or decrease? So yeah, the same thing here. We want to identify it here also. Oxidizing agent and reducing agent. But our main target here is how can we identify the OA, which is the oxidizing agent. So now, if for example I play this is being oxidized. Be careful. This is being oxidized because the number of oxygen here increases towards 6. Why this is being reduced from this, from 0 to what? Minus 2. So the reduced substance is what? Reduced substance is this. Reduced substance, oxidized substance. So if we have this to be by reducing agents, to have been reduced, acting as a reduced substance now. And when the substance is being reduced, it brings about what we call oxidizing agent. So this is my oxidizing agent, while this is my reducing agent. So my answer is what? B. Do you see it now? So you see I have 3 more questions to go. So let's play with 3 more questions here. Yeah. From 2011 down. MnO4 negative plus Y plus 5 Fe Fe2 plus 5 Fe2 plus 4 H2O. Say in the equation above, Y is A hydrogen ion, B 4 hydrogen ion, C 10 hydrogen ion, D 8 hydrogen ion. So we have, okay, Jamb 20 level. Yeah. Another question, okay. Yes. This 1991. 2H2S plus SO2. We have 2S plus 2H2O. The above reaction A is what? A redox reaction is the oxidants, and SO2 is the reductant. B, a redox reaction in which SO2 is the oxidant and this is the reductant. C, not a redox reaction because there is no oxidant in reaction equation. D, not a redox because there is no reductant in the reaction equation. Yeah, I think after you take 2 more, then you can run. So look up the class. I say 1991 and 2011 Jamb question. I say in the above reaction or equation, Y is dash. When I'm explaining the redox reaction, how to balance it, I tell you guys that for you to have your unknown value for either any letter given to you, you have to consider the number of charge you have at the reactant side and also the product side. If that's not the case, you have to look at the reactant side and product side, what is missing there. So now, 4 here stands for the oxygen here, but here we have 5 iron. Here we have 8 hydrogen. 4 times 2 will give you 8. And here they said, what is our Y? If we are to look at the value of I, it means what is missing there and how many hydrogen are we pumping into the equation. 5, no, because the hydrogen here is what? 8. 4 times 2 we have what? 8 hydrogen iron. So the answer is D for your Y. So the next question, the above reaction is what? Is A redox reaction, hydrogen sulfide is oxidant, and SO2 is a reductant. B, a redox reaction in which SO2 is the oxidant and H2S is a reductant. C, not a redox reaction because there is no oxidant in the reaction. No. So C is wrong. B. Not a redox reaction because there is no reductant in the reaction. So C and D is wrong because from this equation here, we have the oxidant, we also have the reductant. But a redox reaction iron sulfide is the oxidant. So let's check now. If this is our reducing agent, and don't forget that your reducing agent will act as what? Oxidant. SO2 is what? Reductant. We are getting there now. A redox reaction in which SO2 is the oxidant and H2S is the reductant. So now, hydrogen sulfide here is being reduced to sulfur. That is our reduced substance. So hydrogen sulfide is wrong. So SO2 is being oxidized to what? Water. So a redox reaction in which SO2 is the oxidant. This is the oxidant. Because this one here is being oxidized towards this. You can see we have 2 sulfur now. And with reactant side we have 3 sulfur, and the other side we have what? 1 sulfur. So question like this, I have to be very careful. So our answer is B, because a redox reaction in which SO2 is the oxidant and H2 hydrogen sulfide is what? Reductant. Don't forget that for every reducing agent, we can also call them what? Oxidant. For every oxidizing agent, we can also call them what? Reductant. So guys, don't forget to subscribe, watch, like, and also if you have any questions to ask, drop in the comment box. Thanks for always subscribing and also always